Hello guys, today we are going to discuss miscellaneous exercise of standard 11 from chapter number 9. Again, I am going to discuss the odd number of questions from this exercise. So the very first question is, show that the sum of m plus nth term and m minus nth term of an AP is equal to twice of the mth term. So we know the nth term of an of an AP is an is equal to a plus n minus 1 into d. So we are required m plus nth term and m minus nth one. So I will find am plus 1 and am minus n. So am plus n is equal to a plus m plus n minus 1 into d according to this formula, and m minus n is equal to a plus m minus n minus 1 into d according to this formula. Now we need to find the sum of both these terms. So am plus n plus am minus n is equal to, addition of these two is directly I have written 2a plus d common, and addition of these two brackets are this. If you apply some calculations over here, you will get 2 times a plus m minus 1 into d, and that is exactly mth term of an AP. Am is equal to a plus m minus 1 into d according to this formula. Hence proved. Let's go to the another question. Say question number 3. Let the sum of n, 2n and 3n terms of an AP be S1, S2 and S3 respectively. Then show that S3 is equal to 3 times S2 minus S1. Right. So we know that the n terms of summation of n term is denoted by Sn is equal to a plus n by 2 bracket 2a plus n minus 1 into d. So summation of n terms is denoted by S1. So I have written Sn is equal to n by 2 2a plus n minus 1 into d. Sum of 2n terms is denoted by S2. So S2 is equal to 2n terms. So 2n by 2 2a plus 2n minus 1 into d. And sum of 3n terms is denoted by S3. So S3 is equal to 3n by 2 plus into 2a plus 3n minus 1 into d. Now what we have to prove is 3 times S2 minus S1. So I was starting from right hand side. S2 minus S1 is equal to S2 minus S1. From both this term, n by 2 is common, and then 2 is multiplied over here. So 4a plus 2 times d into 2n minus 1 minus S1. So n by 2 is common, 2a minus n minus 1 into d. After some calculations, I am getting this kind of term, and then if I multiply this term by 3, I'll get the same term like this way, that is S3. Hence proved. Let's go to the another question. Question number 5. What it says, find the sum of integers from 1 to 100 that are divisible by 2 or 5. So this question is based on in this question we can use the formula of set theory, A union B, right? Numbers of A union B is number of A plus number of B minus number of A intersection B. So we need to find this thing, there is OR. So first I will find the integers divisible, summation of integers divisible by 2. So from these integers 1 to 100, integers divisible by 2 are 2, 4, 6 up to 100. I know the first term, I know the nth term, but what is n? So for that, a is equal to 2, d is 2 and an is equal to 100. So according to this formula, an is equal to a plus n minus 1 into d. An is 100, a is 2, d is 2. After some calculation, I'll get n is equal to 50. Means there are 50 terms in this sequence. So now S50, let us find the summation of 50 terms. An by 2, a plus an, this formula, right? A is equal to 2, an is equal to 100, and after that I'm getting S50 is equal to 2550. Now I'll find the integers, summation of integers which are divisible by 5. So those numbers are from this integers 1 to 100 are 5, 10, 15, 20 and so on, right? So a is equal to 5, d is equal to common difference 5, there are nth term is 100. So using this formula I'm getting n is equal to 20. So summation of 20 terms S20 is equal to, again using this formula, n by 2 into a plus an, I'm getting 1050. Summation integers divisible by 2, summations divisible by 5, and now summations divisible by 2 and 5 means 10. So integers divisible by 2 and 5, that is divisible by 10, are 10, 20, 30, 40 and so on up to 100. In this sequence, a is equal to 10, d common difference is 10, and the term is 100. Using this calculation, I am getting n is equal to 10. Again, summation of 10 terms, n by 2, a plus an, that is S10. So S10 is equal to 550. So as I said, the formula of from the set theory, the sum of all integers from 1 to 100 that are divisible by 2 or 5, that is equal to divisible by 2 plus divisible by 5 minus divisible by 2 and 5, that is intersection. You can imagine like this. So 2550 plus 1050 minus 550, and this is your answer, 3050. That's it. So let's go to the another question. Say question number 7. If f is a function satisfies this condition, f of x plus y is equal to fx plus fx into fy for all x plus y belongs to n natural numbers, such that f of 1 is equal to 3 and this expression is equal to 120. If so, then find n. What is this condition? What is this term? Let's understand this. We have this term, summation x is from 1 to n, fx is equal to 120, means it is sigma. So if I put x equal to 1, x equal to 2, x equal to 3, and summation adding all the terms, we'll get 120. Similarly like this, f1 plus f2 plus f3 plus f4 up to fn, last term is n, up to fn is equal to 120. We have this result. I said it is 1. Now we have to find f1, f2, f3 and so on. So f1 is equal to 3, that is given in the question, and f of x plus y is equal to fx into fy is also given in the question. So if I take x equal to 1 and y equal to 1, I'll getting f of 1 plus 1. The result will be f1 into f1. This will be f of 2. Value of f of 1 is 3. Value of this f of 1 is 3. So I'm getting f2 is equal to 9. To find f3, I'll take x equal to 1 and y equal to 2. So from this formation, f of 1 plus 2 is equal to f1 into f2. F of 1 plus 2 will be f of 3. Value of f1 is 3. Value of f2 is 9. It is 27. So and so on, we can find more terms. But if I put in a number in a page, so I'll get 3 plus 9 plus 27 plus last term is fn up to 120 from 1. Now you can see that this is GP, whose first term is 3, common ratio r is 3. So summation of this term according is this formula, a into r raised to n minus 1 upon r minus 1. So I put this value in this formula, and if I solve, I'll get n equal to 4. So there are 4 terms which we have to find. Let's go to another question. That is question number 9. The first term of a GP is 1. The sum of the third term and fifth term is 90. Find the common ratio of GP. Geometric progression. First term says a equal to 1. Let us assume that the common ratio of GP is r. Then nth term of GP is given by an is equal to a r raised to n minus 1. Now we have given that third term and fifth term. Summation of third and fifth is 90. So a3 plus a5 is equal to 9. a3, a is 1, r raised to 3 minus 1 means 2. So 1 into r square plus 1 into r raised to 4 is 90. If I write it in another way, so I can write r raised to 4 plus r square minus 90 is equal to 0. The factorization of this term is 10 9s are 90 plus 10 minus 9 is 1. So r square plus 10, r square minus 9 is equal to 0. From this bracket, I'll get I square minus r square is equal to negative 10. And square root of negative 10 is not possible. So it is not possible. From here, I'll get r square is equal to 9 and r is equal to plus or minus 3, which we have to find the ratio. And that is our answer. Let's move on to the another question. A GP consists of an even numbers of terms. If the sum of all terms is 5 times the sum of terms occupying odd places, then find its common ratio. Again we are asked to find the common ratio R. So this GP has even number of terms, means it can have 10 terms, it can have 16 terms, it can have 100 terms, and so on, right? So let the GP is AR square, AR raised to 3. Observe that AR raised to 3 means there are 4 terms. Power is 3 but terms are total 4. So to make even number of terms, my last term should be, or last term has the power odd number. So the last term of this GP will be AR raised to 2n minus 1. Now the terms occupied at odd places are, odd places पर जो terms है, the terms are AR square, AR raised to 4, and so on, correct? Now we have what is given, the sum of all terms is equal to 5 times the sum of occupying the odd places, means sum of all these terms A plus AR square plus up to AR raised to 2n minus 1 is equal to 5 times this term AR square, AR raised to 4 up to AR raised to 2n minus 2. Summation of this term is AR raised to n minus, according to that formula, AR raised to n minus 1 upon R minus 1. 5 as it is, AR raised to, see R यहाँ पर common ratio at this place is R square, so R square raised to n minus 1 upon R square minus 1. According, after applying some calculations, we'll get R plus 1 is equal to 5 and R is equal to 4. Thank you.